Hello, everybody. Welcome back to the Doctor is In podcast. I'm your host, Dr. Nadia Saba, president and founder of Dr. Greenhouse. Today's interview is part of our special series, What Plants Crave from Technology, Engineering, and Design, where I'm interviewing equipment providers, engineers, architects, and others about the unique technology and design needs for growing crops indoors and in greenhouses. I'm really excited about today's guest. Dan Dettmers is a senior application engineer at Quest that manufactures standalone dehumidifiers, maybe amongst other things. I consider him the guru of dehumidifier technology and one of the few people I can talk to at a very advanced level about the operation of standalone dehumidifiers and expectations around their performance under a multitude of conditions. Whenever I have a question about how dehumidifiers work, he's my man. I can always expect a thorough response, usually with diagrams, equations, and some colorful words scattered in. You can find him at CA industry events, and he is a tireless advocate for our industry and the unique humidity control needs, speaking at ASHRAE, speaking on behalf of us at the Department of Energy, California's Energy Commission, and a host of other organizations around the country. Before starting with Quest, he worked for 20 plus years in food and pharmaceutical processing, industrial refrigeration, and he's even moonlighted as a hops farmer. So I know we're going to talk about a lot of topics during this conversation. Dan, it's so great to have you on our What Plants Crave podcast. I do have a feeling this is going to be a very popular episode, as everyone in our industry, no matter what they're growing, seems to have this common struggle with humidity control. Everyone except our clients, of course. Anyway, I expect this episode is going to be very enlightening and informative for our listeners. So Dan, welcome to our podcast.
Thank you. I tried so hard to not interrupt through that whole introduction, and
You did good.
I don't know if you noticed, but I had to mute myself because I was
good
laughing
job.
half the time. I just want to ask you, when you say that I have all these colorful words scattered in, do you mean like vapor pressure deficit, latent heat of vaporization, thermophysical properties? Or do you mean those four-letter ones that we typically use in committee meetings?
Yeah, maybe the four-letter ones where you've made bets with others as to how many times I'm going to use one of those colorful words in my talk. So
and I always win, no matter what number I pick. It's up to but not exceed. I always win.
That I am.
Anyway, so yes, I'm excited to be here. This should be fun.
It's gonna be great. So, all right, let's start with who you are. Tell us a little bit about your background and how you came to Quest.
Sure. I mean, the really, really, really long version was by training. I was a nuclear engineer coming out of school at a time when nobody was hiring nuclear engineers. But I found this job working, doing HVAC and refrigeration. Well, after a little while in that field, I quickly realized HVAC, that's dealing with people comfort. And the biggest challenge is we want it to be 70 degrees now. Now we want it to be 72. Now we want it to be 70. It got really boring. The refrigeration, the food processing, pharmaceutical, everything about that was exciting. I mean, freezing chicken nuggets is actually a pretty exciting task. I not eating them, just the whole process of freezing them. So I got really, really involved in that whole industry. And that was where I was for about 23 years. But as you mentioned, somewhere along the line, me and some buddies started basically a hop farm, which started out as, we're just going to grow hops so we can meet brewers and get free beer. And that part of the plan worked, but it grew and grew and grew until we became this whole, we designed drying equipment, we designed harvesting equipment, sold that, we process hops, we were selling from your smallest craft grower to the largest ones. And that was all, I mean, it was a blast, but it was kind of, my wife called it a hobby because it wasn't exactly making a lot of money because, it's farming, right? If any of your listeners understand that. When do you finally get paid in farming? When you sell the farm or you inherit it from your father, right? So I
But
kind of
were
went
you
along with
getting
that.
free beer?
But yes, we did get a lot of free beer because
Okay.
we grew hops that were such high quality that part of the whole shtick was you give us free beer and then you earn the right to buy our hops. So that part was awesome.
Nice, nice.
So eventually, now, eventually what happened was, well, hops are part of the Cannabaceae family, much like cannabis that we're all interested in. And I was actually buying dehumidifiers from Quest. I was a customer, but not for my hops, for curling, right? So ice arenas need a lot of dehumidification to keep frost from landing on the ice and screwing up your pirouettes and figure skating to keep your fog off the ice so you can see that 90-mile-an-hour puck coming at you. And in the case of curling, you got to keep the frost off so your stone does just the right things. Well, I became a good customer there. And then eventually, as I worked on this hop drying equipment, I realized they could use their dehumidifiers there. So I started purchasing those dehumidifiers and building my dryers out of it. Now, eventually, there's a lot of origin stories of how Quest got into the controlled environmental
I
agriculture.
was kind of curious about that too.
Yeah, there's okay, so there's stories the story that likes to be told is that the president of Quest went out and looked into this, or the Cliff Tomasini, he was the original general manager of Quest. It wasn't really either of those two guys. It was salesman number one for Quest. He was this old time guy named Mike. Mike came out to my farm because he wanted to see what I was doing. This was about 2008 or so. He was watching me dry hops with these, and well, Mike's parents lived in Seattle. So when medical marijuana became legal in Washington and then eventually went to rec, Mike's like, look, I need to get free airfare to Washington to visit my parents. Do you think these pot growers need dehumidifiers? I'm like, man, I don't know. He's like, I'll stop out and look into it. So he stopped out at a couple of grow shops in Washington, hit a couple more in Colorado, comes back and he's like, holy cow. He's like, did you know they grow these things inside and they got to take all the water out? So they really need dehumidifiers. So we worked something out, came up with some easy calculations so you could help them with sizing, and boom, Quest kind of starts out in that field. Well, meanwhile, I go and play with my hops for about 5 more years. So then one day I'm walking through the grocery store and I had this like particularly bad day at work. There was something, my chicken nuggets weren't freezing right or something. And I run into Mike and we're talking and everything. And he's like, hey, by the way, you ready to come work for Quest? I'm like, well, would they hire me? He's like, well, they refer to you as the Godfather of pot. Like, yeah, this blew my mind. I'm like, what? I'm the what? Because I was that crazy guy at the time I was working for the university. I was that crazy guy for the university who was trying to dry all these plants and other biomass. And basically, it quickly led to a job at Quest and jumping on this whole train ride of controlled environmental agriculture. Or I'm sorry, you're in California, controlled environmental horticulture. You got to get the CEA,
Yeah,
CEH
right.
right.
You know why they chose CEH? Have you heard, do you know why they have CEH?
Okay, tell the story. I heard
Because
something once.
because CEA was already taken in California.
For
CEA, the
what?
acronym means California Energy Alliance. So they didn't want it to be confusing with controlled environment agriculture. So they came up with their own term, horticulture, which actually, if when I talk to people about this, they're like, well, actually, horticulture does make a lot of sense. And it really does. I mean, we aren't talking about animal agriculture, right?
True.
But yeah, but that's why, because it would have conflicted with the CEA that already existed in California. Hmm.
Okay,
Yeah,
okay.
yeah.
I guess that makes sense.
But the thing
I
is,
still
right?
attribute it to California having to do their own thing.
Well, of course we do. I mean, you know. So you had okay, so that's one of the things I wanted to know about you is how did you get on so you found Quest because you needed Quest to help dry your hops and everything. Then Mike goes out and finds out that there's this huge market for dehumidification. And so is it because of your experience with drying biomass plants using dehumidifiers for the application of plants that got you your foot in the door to be the CEA guy at Quest?
Oh yeah, totally. I mean, before I came to Quest, I mean, you name it, I tried it. Of course, hops, of course, cannabis, spent brewer's grain, lavender, seeds, seeds for oil production, seeds for storage. I mean, this is Wisconsin, right? I mean, we're more than just dairy cows. We have a lot of agriculture here and a lot of stuff that needs to get dried because we got to store it through winter. Because unlike California, our winter, I mean, look at it outside today. I'm talking to you from home because we had like I don't know how many inches of freezing rain followed by snow. I'm not going anywhere. Everything needs to stay dry for storage up here.
Interesting. So, I mean, your comment about ice rinks and dehumidifying for ice, I mean, I guess that makes sense. It's sort of counterintuitive though as well. And of course I want to ask the question. I feel like I'm jumping way ahead by asking it. But how well do the dehumidifiers operate in a really cold environment like that? Is it that cold? I'm trying to think. Like,
Well, it's all kind of relative, right? So when I go curling on Thursday nights, it's 40 degrees in there, and I consider that pretty warm, as does every other guy curling that's in a t-shirt, right?
sure.
But I guess relative for other people, it is considered kind of cold. But yeah, at those conditions, it's not something, the dehumidifiers that you're thinking about for CEH, they're not going to work very well because, we might get into this later on, but a refrigerant-based dehumidifier is basically like an air conditioner in a box. So you're pulling water out by creating a cold environment on a cold surface called the evaporator. And the colder that evaporator gets, the less effective it becomes, right? Because it basically keeps getting colder and colder. And once it gets below 32 degrees, well, now you're building frost on it and you really lose capacity. So for ice arenas, cold storage, a lot of food processing application, we switched to a different technology called desiccant dehumidifiers. Much different technology, doesn't suffer from frost because it basically adsorbs and desorbs the water, and it works really well for those low temperature, low dew point applications, but it's not terribly efficient. Hence why we don't usually recommend it for any kind of CEH application.
Okay.
I guess unless you're doing ice wine with grapes, maybe. I don't know. You'd have to be a really, really cold product.
And I do want to get more into what you just described in a bit and around efficiency, even talking maybe a little bit about some of the differences between refrigerant and desiccant based systems. But let's save that for I don't know, maybe in another question. So I mean, you just started to describe these different applications, refrigeration and ice rinks, the different crops, or plants, maybe horticultural, floricultural plants, that also require some level of drying, if not to dry it, to preserve it, right? So, I mean, in general, how does humidity control for CEA, or CEH, whatever we want to call it, compare to these other applications, where we're drying or preserving something or just being
Sure.
comfortable, right? I mean, even the South. I mean, one of the things that I really like talking to engineers in the South because they understand humidity. California, we don't understand humidity. What's that?
No, yeah. I mean, when it comes to the residential dehumidifiers that my company sells, the 90% of them go to Florida, Atlanta, the Gulf Coast. I think in a typical year we'll sell like 10 units to California because you guys
Yeah.
have perfect weather all the time, or your desert, right? So you don't need it. You guys don't understand what humid really is. The rest of
Mm-hmm.
them we sell up here in Wisconsin, the upper Midwest, and somewhat in New England. For CEA, it's all about the size of the latent load. And when I say latent load, I mean the moisture load, right? So in HVAC world, we talk about sensible load and latent load, sensible being a change in temperature, latent being a change in humidity. So if I'm removing sensible load, it means I'm cooling the air. If I'm removing latent load, I'm taking moisture out. So when you're talking about a building, comfort cooling, the latent load is going to be 5, 10, maybe 15% of the total load. You get to, drying out products. So drying cannabis, drying grape seeds, drying corn, yeah, there's a pretty decent load for a little bit but for the most part, it's not a huge load. You're working really hard to get that little bit of moisture out. The difference is with plants, they're always putting that water in the air. So now all of a sudden the latent load becomes up to 50% of the total load. And that just kind of blows the mind of most HVAC people when they start looking at it. The only other application really that comes close is swimming pools, right? Uh, Again, think about a swimming pool. What is a swimming pool? It's a huge open body of water that's constantly putting water into a very small space and compared to the size of the body of water. Well, think of your grow room application. Again, that plants are taking up almost the same amount of area as a swimming pool would be in that room, all giving off water at almost the exact same rate as a swimming pool. That's the only thing that even compares to CEA.
And I'm assuming that's why indoor pools, are used as the primary analogy when talking about indoor farms. I've even seen, like CFD simulations and stuff where they're trying to model, the latent load or the moisture coming off of a plant canopy, and basically modeling it as like a quote unquote infinite pool, right? Just a source of water.
Oh yeah. And that's why a lot of the larger equipment sold into the cannabis industry. So let's take some examples. Desert Air, right? Their origins was basically in swimming pool dehumidifiers.
Yeah.
So it's very easy to turn that into something that worked for CEA. Agronomics IQ, their parent company is Dehumidified Air Solutions, which was Poolpack, Ceresco, and Dectron, all swimming pool dehumidifier manufacturers. You start looking behind a lot of that equipment, and it was basically equipment made for swimming pools, but then modified for the CEA CH world. The one difference being, for your controls for a swimming pool, if you're in a swimming pool and it's 60%, 50%, or 70% relative humidity, trust me, you can't tell the difference, right? You're not going to notice.
Not a lot of people are going to be complaining about that.
Nope. But your plants, if it's 50% versus 70%, they're going to notice a difference, and you're going to see a difference in their growth rate and transpiration rate. So, the controls is the biggest part, and refining the control to get that equipment to hold a closer and tighter temperature and dew point.
Yeah. So, I mean, following up on that, I mean, if we have figured it out, say for indoor pools, what exactly is it that makes plant environments so much more challenging to manage the humidity? I mean, you mentioned one thing, which is, we have growers anyway have a lower tolerance for a range of humidity conditions. That doesn't mean the plant does, but growers certainly do. But beyond that, what makes dehumidification so damn challenging for this industry?
I'm gonna
and
go
this
back
might
in
be a
history.
30-minute long list right now, but
yeah. Let me answer that by giving you a 12-minute story. So, being from Wisconsin, of course, I fit every stereotype possible, right? I was drinking beer when I was 3 years old, and I grew up on a dairy farm. And I remember getting done with high school and saying, Dad, I'm done with this. No more dairy farm, no more animals, no more driving a tractor. I'm out of here. I'm going to nuclear engineering because that has nothing to do with agriculture. Yeah. When I started the hop farm, do you know how hard he laughed? I mean, here I am back, right?
Yep.
And the reason I didn't want anything to do with it was because biological life forms are so chaotic. They don't do anything the same. So think of that swimming pool application, right? The pool is always the pool. The size doesn't change. The evaporation rate, I mean, it only changes a little bit. The only time it gets really drastically out of whack is when some kid has a swimming pool birthday party and there's water splashing all over the place. Otherwise, everything's pretty stable. But now think of a flower room for cannabis or, leafy green room. they start out teeny tiny with a teeny tiny latent load, and then they keep growing. And as they grow, the transpiration rate changes, the latent load changes, the sensible load changes as your lighting changes. Everything's always changing. So you can't just design for one set of conditions like a swimming pool. You can't shoot for, I'm always going to hold it at 72 degrees like a office building, because the growers want this temperature and condition at night, this temperature and condition during the day, different conditions throughout their lifetime. And then when, especially in cannabis, you get to the end of their life and, some growers really want to push either colder temperatures or drier. I mean, man, from the designer standpoint, the engineer standpoint, you're just asking for so many variables, so many different changes that the design becomes a little bit difficult, at least way more of a challenge than a swimming pool.
So that's on the design side. I mean, what about the equipment itself? Can it handle those variabilities in the environment, or what do you do about that?
It it can, right? But you have to come into that with your eyes wide open. So a lot of times when I see a design come across, I'll have an engineering firm or a manufacturer's rep or a owner themselves bring a design to me and say, "Hey, Dan, what do you think? We want to bid out this equipment." If I look at the flower room and there's one big dehumidifier in there, I go, "Hold on, time out. What's going on here?" And the guy's like, "Well, you said my load was going to be 40 pounds per hour, and that unit does 42 pounds per hour. So I'm great." Like, no, you'll be great for the last, 2 to 4 weeks of your growth cycle when that's the actual load. But think about all the other times when those plants are tiny and you've got a load that's only 10 pounds per hour, and then 20 pounds per hour, and 30 pounds per hour. Or think about your veg room. Think about all the other rooms and all the variability. You need to design a system that has built into it the ability to ramp up and ramp down, do so efficiently, and do so with the ability to meet your needs, whether it's changing sensible, changing humidity levels, whatever you got going on. You have to think about the design through the whole life of the plant, not just that peak time.
I love that you take that approach. I feel like there's still a lot of engineers and even growers and manufacturers for that matter that are still on that learning curve. For us, if we are picking standalone dehumidifiers, yeah, we do exactly what you said. If it's 40 pounds, we might choose two 20 pounds, or maybe we'll choose four 10-pound units, right? And stick one in each corner so that we get some distribution of that dehumidification load, but also it gives you staging opportunities, kind of like having multiple compressors, right? In your air conditioner, or multiple stages of compressors. It allows you to turn things on and off as you need them. So you're not overshooting the dehumidification, right? And then undershooting it to sort of recover from over dehumidifying. Um, yeah. So I think that's a good design strategy.
Absolutely. You hit it on the head. I mean, the worst mistake you can make is a single dehumidifier in that room that's either on or off. It guarantees that you're going to over dry, and then you're going to have to wait till it goes over the top. So multiple dehumidifiers, whether you're talking standalones or if you're using packaged units or if you're using like a chilled water system, you want to have that variability in the way to ramp it up and ramp it down. So a lot of times when people are putting in standalone dehumidifiers, I'm like, use two, use three, use four. And even though you can gang them all together on a single controller, don't do that. Split them at least into two stages. So you can bring half of them on and then bring the other half on. Because now you have all these ability for staging, use it. Let your controller, whether, whoever's controller it happens to be, bring on one, bring on a second, bring on a third, ramp it up, ramp it down. So that way you're not, in the nuclear industry, we call it the bang bang theory of control, right? That was when you took your nuclear reactor and you hit it on full speed and it just ramped up as fast as you could, and then you turned it off and you shut it down as fast as you could. Great way to run a nuclear reactor. Not a good way to run your
Why, I
operation.
have to ask, why is that a good way to run a nuclear reactor?
Because you
That
want to
sounds
get
so
that
dangerous, no?
You want to get it up to power as fast as you can. So there's various transients that occur when you're creating radioisotopes within the core. So you want to get it up to running as fast as you can, and you want to shut it. Well, hopefully you have plenty of time to shut it down. But once in a while, things happen, and you got to shut that reactor down pretty quick. So, do you really want to get into this? Because this could be another 2 hours of your
No, no,
podcast.
no. But I mean, I have to tell you why I'm thinking about this is because we have run across a few clients who have hired, big clients, and they've hired like these big teams, and sometimes some of like the main like facilities guys came from like a power plant industry. And so I'm thinking about someone in particular who's like, I ran a nuclear power plant for 30 years and I don't understand why this is so complicated.
And that's
Now
where,
I
if you
know the
want the most
answer.
insulting response to him, you say, "Look, Homer, grab a donut, sit back, and I'll explain this to you."
Well, I asked him actually, did your plant grow plants? That's what I asked him in retort.
Hopefully not.
No. Anyway, so you just like, answering some of those background questions in my head, just yeah. Anyway. Okay, so standalone dehumidifiers. So you started talking about, that they're like an air conditioner in a box, right? They have an evaporator coil. But, when I think about an air conditioner, usually the air conditioner, or at least part of it, is sitting outside. With these standalone dehumidifiers, one of the nice things, convenient things, is that it's, it is a package, but it's sitting in the room. Usually, sometimes we see them kind of set outside and they're recirculating. Why? I mean, are there other advantages to having a standalone dehumidifier as like a box that's sitting in a room? I don't
Well,
know.
the biggest advantage of it having all self-contained in a single box is the ease of installation, right? Think about your home air conditioner. So a lot of people have what's called a split system, and you might have those in your grow operation as well, where you have the evaporator sitting inside, and then outside you have a condenser, your compressor. It's all in that box that sits outside that always gets full of leaves and dust. And by the way, please clean that off every once in a while. That's your heat rejection. You need
For
that
reals.
clean, right? So there you've got the problem with installation is you got to run refrigerant lines from inside to the outside. Refrigerant, well, otherwise known as Freon. There's all kinds of federal and state regulations as to who can install that, how you can run that, where you can run it, how far you can run it. So that needs to be installed by a professional. It takes a lot of time and money. Whereas your standalone dehumidifier is just a single box. I mean, pretty much anybody can hang in the space, run a line. So that's number one. Number two is, boy, it's a good thing, it's a bad thing. So that standalone dehumidifier, since everything's inside the same box, all the energy it takes out of the air, all that latent energy it takes out of the air, it's got to give that energy back, right? So it's got to come back into the air, but it can't go back in as latent, right? We can't put it back in as water. So it basically, the box turns it into sensible energy. It turns it into heat. So when you put your hand at the outlet of a dehumidifier, it feels warm because basically for every 1 pound of water you take out of the air, you're adding a little over 1,000 BTU of heat to the space. Okay, is 1,000 a lot or little? Well, 12,000 BTU per hour is called 1 ton of air conditioning or heat. And your typical home is usually a 2 to 4 ton load, right? So that kind of gives you an idea. So the standalone dehumidifier or even some of your other units or other technologies are going to end up putting that heat back into the space. Is that good or bad? Well, during lights on period, it's not the best thing because it means your air conditioning is going to have to take that heat out. During lights out period, though, well, a lot of you know that you're running heat because all the evaporative cooling by the plants during lights out, I hesitate, I always say nighttime, right? I know nighttime could be at any time of the day, but when the lights are out, the plants are still transpiring, there's still evaporative cooling going on, but there isn't all that heat from the lights. So you sometimes have to put heat back in. Well, that's where that little bit of heat from a standalone dehumidifier or even some other technologies is a good thing.
Yep. And I know a lot of growers who have, maybe in their mind leveled up to a package system, right, that can do the cooling, the dehumidification, and the reheat or the heating all in one package, many of them don't realize the importance of heating that air back up after that dehumidification process to maintain their temperature. And if they didn't have an auxiliary heating system or supplemental heater, if they have hot gas reheat, well, when the lights are off and there's not a lot of latent load, you might not have enough heat to recover in order to raise the temperature to what you want it to be. So if you didn't have that auxiliary heater, you might be overcooling your room. We always specify an auxiliary heater. No matter how much we get pushback from the manufacturer, we say, nope, I don't care. We need at least 10 kW something in that duct or in that unit. And sometimes we install a duct heater because they just won't do it, or they didn't design their system to accommodate a heating element. And so it's like, well, we're putting it in there. And I've only ever heard growers regret not having it, not having it. That makes sense. Double negatives, those are fun.
No, don't ask me. I'm an engineer. I ain't not know nothing about grammar.
Okay, so since we sort of started veering toward, okay, so you described the standalone. By the way, I mean, really good point about it being easy to install. Anyone can do it. All you need is like a plug, right? I mean, it's like 120 volt type of thing.
120, 220, as long as you got the power there.
Yeah.
I've seen them sitting on the ground. I see them suspended from the ceiling. I do see there is a trend now, you're right, towards putting them outside the space and just ducting the air from the space to the unit and back to the space, to give a cleaner look. And, basically, I guess growers get tired of bumping their heads into the units.
Yeah, maybe.
I can understand that.
You keep the condensate out of the room too.
Right.
Yeah. Okay, so now let's talk about our friends on the other side of the aisle. Can I say that? The packaged unit systems. Our country's way too political these days. It's just like all the jargons in my head.
Yeah, wait. Am I the good guy or the bad guy? I guess since I'm on your show, I'm the good guy at the moment.
Yeah, I mean, they're not the bad guy either. They just have a different perspective. Right? Okay.
Right.
Okay, so anyway, so the package systems. So so you just described you have all these things in a box sitting in the room. The package system that I just sort of described, right, having all these pieces also in the same box, but outside the room, but having not just not just focus on dehumidification, but focus on cooling. It's not dumping that heat back in the room, right? And then it's controlling temperature and humidity at the same time. I know that's not what you specialize in necessarily, but you are the dehumidification expert. So can you explain a little bit about that system and how, at least maybe the biggest differences between these two different types of systems?
Sure. So an air conditioner, really an air conditioner is an air conditioner, whether it's a split system or packaged one, like we were just talking about. In both cases, there's going to be an evaporator that takes the air, cools it down, and then the refrigerant is going to take it to a condenser, which then rejects the heat to the great outdoors, right? It's usually to air outdoors, but it could be to some source of water, whether it's a cooling tower, a fluid cooler, or something like that. Now, our package units, they're conveniently packaged in a single box. And like you said, they have to be outside because they have to reject that heat out there. But once in a while, people call it like an all-in-one system because it provides dehumidification. Like, okay, so how does it do that? Well, basically, by turning it into a rudimentary dehumidifier. So much like our dehumidifier is built to have the air go through the evaporator and the condenser and then back into your space. What they do is put a second coil in there, and it's to do something called hot gas reheat. So instead of sending that refrigerant gas to the outdoor condenser, it's sent to this basically indoor condenser. So now as the air goes through the evaporator, it cools off, then it goes through this condenser to reheat, and now it comes back into the space. Does it work? Sure. It works really well. Is it as efficient? Not really, because it was really built to be an air conditioner, not a dehumidifier. And that's where things kind of go awry. So when you have a system like that, you always have to send a little bit of refrigerant to that outdoor condenser. So you never get back all the heat or even more than what you started with. So you're going to end up having to add a little bit of heat during the lights out period. And it's not going to be as efficient as the dehumidifier because, it's kind of, it's like using my wife's Prius to haul lumber home from, Home Depot or Lowe's. It works, but that's not what it was built for. You should really use a pickup truck or a trailer. That's what it was built for, the right tool for the right job. Or I guess a better analogy that I just ran into the other day is when you need a hammer and the only thing in your hand is a ratchet, it works as a hammer, but then it'll never work as a ratchet again because you will destroy it.
So, I mean, for these systems that were originally pool dehumidification systems, that have been sort of repurposed, reconfigured for indoor grows. I mean, weren't they originally developed as dehumidifiers first and then air conditioners, or were they still air conditioners that were kind of tweaked to be more dehumidification focused?
Dehumidificationally focused? Let's make up a new word here.
Let's do it.
Yes, those swimming pool dehumidifiers are dehumidificationally focused air conditioners. And right now the guys over at Desert Air are listening to this and they're about to start calling me.
They're hating you.
Like, Dan, stop it. I'm not as afraid of them as the guys at Egg IQ because technically they're part of the same company as Quest. So I know that they're gonna come back with.
They're gonna love this.
So yeah, I mean, in those cases, yeah, those are really dehumidifiers first that were designed to also provide cooling. Hence why you're going to see much better efficiency and performance out of them for both operations. But of course, if anyone's ever priced them out, you understand that the price for those is going to be considerably more than your packaged rooftop unit with a hot gas reheat coil shoved back in.
I mean, what is fundamentally different between a package unit that's more dehumidificationally focused and one that's more cooling focused? Is it?
You're just trying to use that word as much as possible.
I am. I'm going to as much as possible. We're going to see it in the Oxford Dictionary next year. Everyone's going to start using it.
Sure. I mean, the integrated HVAC. We're going to use. There we go.
Okay.
That's the terminology that California has cemented in all our minds. The units that used to be swimming pool dehumidifiers that have now been, redesigned for the controlled environmental horticulture world are appropriately called integrated HVAC systems because they're often, there's usually heating in it, there's always air conditioning, there's always dehumidification. And what they do is those are designed specifically to be able to vary the amount of reheat. And I guess I should step back. I've used this term a couple of times and we didn't really define it. Reheat is the act of reheating the air that we just cooled off, right? We take that air, we have to cool it off in order to pull the water out. But if we dump all this cold air into our space, it's eventually going to get really cold. So we have to heat it back up. Preferably, we do that with some heat that's been recovered, recycled, or comes from the sun, right? And that's California's new regulation, is that 75% of the reheat energy has to come from one of those sources. Well, in the case of a dehumidifier or an integrated HVAC or even a packaged unit with hot gas reheat, the source of the heat is just taking the heat that you took out of the air to get the water out and you're putting it right back in. So that's site recovered. It could also be heat you recover from some other process. Maybe you've got another room that you need to cool off. You could take that heat and dump that in. You could use solar collectors, anything like that. What they don't want you to do is use electric resistance or burn some fuel in order to heat that air back up. Because think about that for a second. You just paid a whole bunch of money to cool this air down to 60, 50, maybe even 45 degrees. And now you're going to go and pay a whole bunch of money to heat it back up again. I don't know about you, but I don't have that kind of money. I'd rather use some free heat that I got laying around. And so that's what the integrated HVAC does, is it does a really good job of being able to vary the amount of heat that it takes from its recovery only put the amount of heat it needs back into the space, and then dumps the rest outside. A standalone dehumidifier, we can't control it like that. We got to put all back in because we're all in one box. The packaged reheat with the hot gas reheat coil, some can, some can't. It depends upon how much you're willing to spend on the original design of that unit.
What about, I mean, the evaporator coil part of the equation? You had mentioned earlier with humidity control for thermal comfort for people that, the humidity can kind of range between 40 and 60 or 70% before people are uncomfortable or complaining. But here, and there's not really a big latent load unless maybe you're in the South. But in CEA projects, we have a high latent load. And so we need to suck a lot of moisture out, but we also need that tighter control. So, I mean, with air conditioning, most people, well, maybe not most people, but people may know that just through the process of air conditioning, we do a little bit of dehumidification. So with these, integrated HVAC systems that need to suck out more moisture, do they need to drop the temperature of that evaporator coil more than, say, a thermal comfort air conditioner?
Uh,
Is there some magic behind that?
oh yeah, I mean our primary refrigeration design engineer's favorite joke when he's walking the halls of Quest is, "What's the difference between an air conditioner and a dehumidifier?" "About 5 to 10 degrees on the coil." Okay. He thinks it's funny. The rest of us laugh
It's
every
not
se-
really that funny, but
Oh,
it's more like fact.
yeah. Okay. And Scott, if you're listening, sorry. But his point being, right, when you're talking about comfort cooling, the coil temperature is going to be 5 to 10 degrees colder than whatever the air is you want coming off. So if you want 55-degree air coming to your space, your coil temperature is going to be 50 to 45 degrees. And that's enough to pull some water out. But you honestly, in that coil design, you don't want to pull too much water out, or the whole coil will get choked full of water and you can't get any airflow through it.
Mm.
When you start talking about a dehumidifier or these integrated HVAC systems, first off, you pick a coil and a coil design that sheds water really quickly. So it's designed to expect to have a lot more water on it so it can get the water off really quickly so the airflow can get through it. And then you design it to have about a 15-degree temperature difference between the coil temperature and the temperature of the air leaving. So if it's 55 degrees leaving, you're going to have like a 40-degree temperature on your refrigerant coil. And that's basically, the colder it is, the more water you're going to pull out of the air.
Interesting. Are there issues with the refrigerant itself operating at such a low temperature? Is there a limit?
So the refrigerant itself, nah. The
Okay.
equipment, yeah. So if we're talking a 15-degree temperature difference, so the refrigerant itself, no, the refrigerant, I mean, that can operate at just about any temperature. It's just a matter of dropping the pressure or increasing the pressure to get a different temperature. The equipment, though, especially that evaporator coil, that's where you have the problem. So think about, nighttime conditions, or I'm sorry, lights out conditions of like 70 degrees, 50%. That's a dew point of around 50 degrees. Dew point being the temperature at which water falls out of the air. Well, if I want to get a lot of water out of the air, I want to be 15 degrees below that. So now 50 minus 15, we're talking 35 degrees. Ooh, that's getting cold, right?
Yeah.
What if I want 70, 40? 70, 40%? Now that's a 45-degree dew point, which means I'm now down at 30 degrees. What happens at 32 degrees? Fahrenheit, of course. Stuff freezes, right?
Yeah.
So now all that moisture that's coming out of the air, it's not coming out as water, it's coming out as frost. And it starts to choke up that coil and build the frost. And this has a problem for two reasons. One being that it reduces airflow, and a reducing airflow gives us a reduction in capacity. And two, it it takes a lot more energy to pull water out as frost or ice than it does as water. So we're losing a whole bunch of capacity at this point. Plus, every once in a while now we have to stop defrost, which simply means we shut off the machine. Well, we shut off the compressor. The fan continues to run to provide a little bit of heat. We melt that frost off, and it goes back into service. So again, another good reason, going way back in our conversation, why you don't want to have just one dehumidifier. If you get to conditions where you're frosting up your coil, that means for 2 to 5, maybe even 7 minutes, depending on how big the machine is, it's going to shut down and not provide any dehumidification in your space while it's defrosting. You want to have a couple, 2, 3, 4 units, so that way you're pretty much guaranteed that they're not all going to be in defrost conditions at the same time.
So, I mean, I love that you brought up defrost because I know that that has frustrated a lot of growers. We've had a few clients where we've helped troubleshoot their existing equipment, and they're like, "Oh, we just want to disable this defrost mode because they're not getting anything. They're not getting any airflow, right? Like they're
Oh
and
no.
they're yeah."
If you completely disable it, then your evaporator will turn into a block of ice, and then you definitely won't get any airflow.
Yeah, I also visited a grower who did that, and their
Mm.
motors were catching on fire, their supply fans. Yeah.
Oh my
So that's
goodness.
one way to melt the ice. Fire.
Yeah, fire does melt ice, but only the first time. Yeah, I mean, we have growers all the time. They call us. They're like, "Oh my gosh, we just looked inside the unit and there's ice all over the coil." Yes, there might be. Relax. Just relax. It's going to go through a defrost mode. The machine is designed to operate that way. Now, you know, talk to, in the case of us, talk to one of your Quest representatives or whoever your preferred dehumidifier manufacturer is, and they'll talk you through, what units they have that do better under lower temperature conditions or lower dew point conditions, because not every machine is designed the same. So a lot of times, I mean, any standalone dehumidifier is designed to go through that process. Any integrated HVAC system is designed to go through that process. Not every HVAC system is, though, whether it's a split system air conditioner or a packaged unit. Not all of them are designed to go through defrost, because they are built for the commercial cooling environment, right? For office buildings, for schools, for libraries, you're never going to hit a dew point so low that you have to go through a defrost cycle. So if you're specifying that equipment and you're expecting it to do a lot of dehumidification, talk to whoever you're buying it from or whoever's designing your system and say, "Hey, I'm expecting to actually run this at 65 degrees 50%, or 70 degrees 40%, or someplace where my dew point's low enough that I might build ice on the coil. Is this equipment still going to work?"
Yeah.
And it's a fair question, and hopefully they think about it for at least 3 seconds before they give you an answer.
I mean, this is a really good point, and it's making me think too, because we always seem to bottom out at a leaving coil temperature in the upper 40s usually. And so when I think about your 15-degree delta, right, minus 15 from say 48 is 33, right?
Yep.
So we're just right above that freezing point. So it's not actually so maybe what they're doing is they're saying, well, we limit it to this 47.6. I mean, literally, right? You'll see these numbers in our submittals. And that's because they're building in, right, the safety to prevent freezing. Otherwise, then maybe they would need the defrost cycle, or would the defrost cycle still be there regardless, just in case that happened? Or does the manufacturer limit it at the factory, like it's not going to go lower than this to prevent freezing? Or does it, maybe it depends, I guess, on the
Yeah,
equipment.
it depends upon the manufacturer. I mean, especially with air conditioning equipment, they're not expecting it to end up in the cannabis operation in California or a leafy green operation in Vermont. They're expecting it to go into somebody's house or office. So they may or may not have those controls installed. And that's where you kind of need to have that conversation and say, this is what I'm expecting to see. Now, that's where throwing in your dehumidifier to take care of that latent load will keep your air conditioner out of those circumstances, out of those conditions. And I do have to say, there's a lot of applications where I get the phone call after the facility is built, after it's up and running, where somebody went, "Oops, I didn't expect there to be this much water in the air. What can you do to help?" And that's where we'll start retrofitting dehumidifiers in there to take that latent load so the air conditioning doesn't have to get down to the conditions where there's any danger of frosting up.
Mm-hmm. I mean, do you guys have the same minimum threshold, like 47 degrees is like your minimum coil temperature ish?
So in our case, our unit will just kind of keep going and going and going, and it'll basically hit a temperature where it goes into defrost.
Okay.
Um, it's more of a physical limitation. You hit the point at some point where the dehumidifier, the evaporator coil will just build the frost, and then when it goes into defrost mode, well, that warm air coming and blowing on it, some of the frost is going to melt. Some of it's going to do what's called sublimate. So sublimate
Yeah.
is when you go straight from solid ice to vapor, to water vapor in the air. Well, at some point you get to the point where more of the water sublimates back into the space than hits the drain pan, and effectively the unit's not really doing any good for
Ugh.
you anymore.
Yeah.
Um,
So do you have I mean, I'm just going to ask this question. Do you have a
yeah,
rule of thumb for growers? Like, and
yes,
you do?
45.
There you go. Okay.
I don't care if it's 45 degrees or 45-degree dew point. Stop.
Okay.
Stop. Don't go below that without talking to me. Honestly, with temperature, well, I haven't. I guess I saw one operation that was at 50 degrees once. I've never seen one down at 45 degrees. It's more that 45-degree dew point. So 70 degrees, 40%. At that point, let's have a really serious conversation about maybe switching to desiccant technology, because at that point, now you're going to lose so much capacity that you need to know what your unit's going to do. Honestly, 40%, regardless of the temperature, is kind of like the danger zone. That's where we
Okay.
need to start having a conversation.
So that was a great segue because, and you brought up desiccant earlier briefly, but why is desiccant not more prevalent? You mentioned earlier it's not very efficient. What does that mean? And, yeah, I guess why don't we see desiccant in normal operations, but you would, I think we would both recommend it at these really low dew point conditions. Why?
Sure. The biggest is the efficiency of the unit. So I like to hearken it, and since I actually take care of our desiccant line as well, I spend a lot of time comparing. And refrigerant dehumidifiers are kind of like the sports cars of the dehumidifier world, whereas desiccants are the Mack trucks, right? So your refrigerant dehumidifier, as temperature and conditions, as that dew point goes up, as the dew point comes down, as the temperature and relative humidity goes up and goes down, so does the capacity and so does the efficiency. So, for example, our Quest 335 that we just came out with about a year ago, at 80 degrees, 60% relative humidity, I mean, we're talking about 9.3 pints per kilowatt hour, meaning you're getting 9.3 pints for every kilowatt hour of electricity. You drop that down to 70, 50%. Now you're down to about 6.9 pints per kilowatt hour. You drop that all the way down to 70, 40 or something less, you're going to be down in the range of 2 to 3 pints per kilowatt hour. Now compare that to a desiccant. At 80, 60, a desiccant's going to be doing about 1.6 pints per kilowatt hour. At a dew point of minus 20, it's going to be doing about 1.2. There's not a lot of change. It doesn't get any better, but it doesn't get much worse. It just keeps trucking along, doing its job, which is great, but it's doing its job really inefficiently. So when you're looking at a desiccant, it's going to cost more to purchase the unit per pint of capacity. It's going to cost more to install it because there's a lot more ductwork that needs to be installed, and most of them are going to be 460 volt 3-phase instead of 220. And then it's going to cost more in the long run to operate. So whenever somebody comes to me and says, I want a desiccant dehumidifier, I stop them. I say, why? Let's talk this through. Why do you really, really need one? And if they convince me they really, really need one, then we'll talk about selling them one. But you got to convince me that you've got some reason that you need to be at really low temperature or really low relative humidity. Or I have run into it a couple times where someone had a really unique design where they needed low dew point air, and it actually did save energy. Very unique designs, I'll put it that way.
What makes them so inefficient?
It's the process. So the whole process of the way a desiccant works is air goes through the silica gel, and it's the same stuff that, you buy shoes, you buy electronics. There's that little packet that does desiccant, do not eat. Well, that's a water scavenger. It grabs any water that comes into that package and holds onto it. Well, eventually it becomes full. So the only way to regenerate it, to push the water out, is to throw it in the oven and bake it, right? Well, that's not very effective. I don't know many leafy green operators that would want to fill their room full of desiccant packets and then take them home every night and throw them in the oven, right? Not going to work. So instead, what we do is we put it on a honeycombed wheel, and we bring air from the space. It goes through this honeycomb wheel that this desiccant sprayed on. The desiccant sucks up the water. Now, in the process, it's an exothermic process, so it does give off a little bit of heat. Not typically as much as you'll get off of a standalone dehumidifier, but still some heat. And now that warm, dry air goes to the space. But as that desiccant gets saturated, we put it on a wheel, because that wheel's slowly turning, and it turns into a second airstream. The way we regenerate it is we take air from outside, air from the hallway, air from someplace else, bring it in the unit, and heat it up to about anywhere from 200 to 280 degrees Fahrenheit. Push that through the wheel, that dries the wheel out, and then we take that warm, humid air and we throw it away. Well, now that's heat that we're not recovering to reheat our space at night. That's a lot of energy we're using in order to dry that wheel out. That's why it's such an energy hog, because just fundamental way of how it works.
And there's no way, I mean, we're dumping out this warm, humid air off of the desiccant to dry it. I've heard people ask this question, of course, like the next question, well, I don't know, of course, but like one of the first questions that I think of is, we're also losing the opportunity to potentially collect the condensate, right, from that dehumidification process. But then you think, oh, well, let's collect it and then let's run it across a cooling coil and condense the water out. And what did we just do?
Right. Now you're using energy on top of energy on top of energy.
Tune in next week to hear the rest of our interview with Dan Dettmers. And as always, thank you for growing with us.